All right, next we're going to talk about initial conditions and particular solutions. So just a leading question here. Can you find the equation of a line given a point and its slope? If so, explain how you would do so. Well, can you find an equation of a line given a point and its slope? Well, the answer is yes. And what I would probably do is use point-slope formula. So y minus y sub 1 equals m times x minus x sub 1. Okay, so m would be my slope here, and then my point would be x sub 1 comma y sub 1. So find the equation of the line f of x given the slope of the line is 3 and f of 1 equals negative 2. Okay, so we know our m equals 3 and we know f of 1 equals negative 2. So how do we find a point out of this? Well, this right here is actually our x value. So this gives me the point 1 comma negative 2. So what I do is plug it into my formula. Y minus y sub 1 equals the slope 3 times x minus x sub 1, which was 1. And then you would just solve this. So you'd get y plus 2 equals 3x minus 3. And then probably subtract over the 2, and you'd get y equals 3x minus. Okay, so that's total review there. And because you know the general solution for every line is y equals mx plus b, you can determine a particular solution for the equation given an initial condition and the slope of the line. So the question is, can you find a particular solution to any equation given a point and its slope? If so, how would you do so? So now this is to any equation. Notice the difference from a line up here. So looking at that difference, if we're talking any equation, we can totally do this. What we would want to do is, if we're given a slope, that's going to be its derivative. So if we can integrate the slope, and just to show that it's a derivative, we're just going to say dy over dx. Okay, so we're going to integrate the slope, and then we would plug in our point, and then solve for the constant of our general antiderivative. Okay, so here's an example of what we mean. It says find the particular solution for the equation having a derivative, capital F prime of x equals 3x plus 4, with an initial condition of capital F of 2 equals 6. So when we look at this, we have to see this as being our slope. So what we're going to do is go ahead and integrate our 3x plus 4. Okay, that's this part right here. Integrate the slope. And that'll be with respect to x. So we're going to use our power rule for integration. So we get 3x. That's going to go up by 1, and then divide by that power. And then integration of a constant is just going to be 4x. And then we have that plus c. So really all we're trying to do here when we're finding a particular solution is figure out what does that c have to be if we know that f of 2 at least is 6. Okay, so here's what we're going to do. We're going to say 6 equals 3 halves times 2 squared plus 4 times 2 plus c. Okay, so do you see what we did there? We said we know x equals 2, and so we substituted it in to our indefinite integral. And we knew f of 2 equaled 6, and so we put 6 right here as the answer. And so we want to figure out which constant is going to give us 6. Okay, so here we get 4 times 3 halves, so that's going to be 6, and this is going to be plus 8 plus c, and that equals 6. And then if we're going to solve this, subtract the 6, subtract the 8, so we have negative 8 equals c. Now once you find c, you're just going to substitute that back into your indefinite integral. And so we're going to get capital F of x equals 3x squared over 2 plus 4x minus 8. Okay, so again, we just integrated the slope. We plugged in the point into the indefinite integral, and then we solved for c and plugged that right back in. Okay, so the directions are written out right here on how to do these. And I want you to go ahead and try 1, 2, and 3 on your own. Go ahead and pause the video and then come on back when you're done to check your work. Alright, just take a second here and check your work and check your answers to see that you're able to find your indefinite integral. Okay, and then you were able to plug in and solve for your c, and then just substitute that back in. So check 1, 2, and 3, and when you're satisfied that you understand how to do this, you can unpause the video, and then we'll go on to the next example. All right, in our next example, here they give us a second derivative. And so we're going to have to do this process twice now to be able to figure out what f of x is going to be. Okay, so we're told two items of information here, that f of 0 equals 3 and f prime of 0 equals 4. So we're given an initial condition for the derivative and an initial condition for the function. Okay, and we know the function for the second derivative. So what we need to do is go ahead and find our first derivative by finding the indefinite integral of this right here. So I'm just going to write that out. Okay, and so if we wanted to do the integral of 5 cosine x, that's going to be 5 sine x, and then the integral of negative 2 sine x is negative 2 cosine x, and then we have that plus c. Now we have to figure out what that plus c is. So we know f prime of 0 equals 4, and this is going to equal 5 sine of 0 minus 2 cosine of 0 plus c. And so sine of 0 is 0, and then cosine of 0 is 1, so this is just going to be minus 2 plus c, and that equals 4. And let's add 2 to the other side, so we know that 6 equals c. And so my f prime of x is going to equal 5 sine of x minus 2 cosine x plus 6. Okay, so I just took that equation and I plugged my 6 in for c. Now we're still left with the derivative. We want to find that original function. So if we want to find f of x, that's going to equal the integral of our derivative. So of 5 sine x minus 2 cosine x plus 6, and that's dx. Okay, so we're just going to run the indefinite integration. So the indefinite integral of sine is negative cosine, so we get negative 5 cosine x. The integral of cosine is sine, so we get negative 2 sine x. And then the integral of 6 is just going to be 6x. And this was indefinite, so we're just going to go plus c. Now in this case, we have an initial condition right here, that f of 0 equals 3. So I'm just going to write f of 0 equals 3, and that's going to equal negative 5 cosine of 0 minus 2 sine of 0 plus 6 times 0 plus our constant. So again here, cosine of 0 is going to equal 1, and so we get negative 5. Sine of 0 equals 0, so that's just plus 0. 6 times 0 is 0, and then we have plus c, and all of that still equals 3. So it looks like we add 5 to the other side, and c equals 8. And so our original equation, f of x, will equal negative 5 cosine x minus 2 sine x plus 6x, and then plus c, which is 8. And here is our original problem. So again, when you're given the second derivative here, what they're going to do is give you initial conditions for both the derivative and the original function. And so you just have to run the process twice through to get back to the original function. All right, for problem 5, we have the same situation where we're given a second derivative and then an initial condition for the derivative and original function. So I want you to go ahead and try to find that f of x, that original function, and give it a try on your own. Go ahead and pause the video and come on back when you're done to check your work. All right, welcome back. So here is finding our first derivative. So we had to integrate the original function, which I just rewrote. And we got that plus c, and then I just simplified that, so it would be times 2. Then I plugged in my initial conditions here, and I found that c was 3, and so we had 2x to the 1/2 plus 3. Then we had to go one more step further, so to find f of x, we had to integrate the derivative. And so here we were integrating this function, and again, it's just power rule for integration. And then I simplified, divided by 3/2 to make it 4. And then I plugged in my initial conditions. So I plugged in 4 for x, and that equaled 25. And then I solved for c, which was 7/3, and then plugged it in. And so my original function, with these initial conditions and a second derivative here, is this one right here. All right, so that has been solving differential equations with initial conditions.